Hi everybody, welcome back. In this video I want to move on to topic 4.3, which is called Aquatic Food Production Systems. And as usual, I think that's too much to go through in one clip, so I'm going to split it down into at least two videos. In this first video, I just want to look at the human demand for aquatic resources. I wasn't sure what to put in the box above my head, but in the end I went with this map. I got it from the NASA website. And it's a map of productivity of water bodies all around the world. Now you might have to train your eyes to see what it actually shows. The grey areas are land masses and the rest are water bodies. In the centre you've got the Pacific Ocean. Here's the Atlantic. And then here you've got Asia, Africa, with the Americas in the middle. And what you can see from that, I will go through it in a bit more detail a bit later on in this video. Most of the world's oceans and water bodies are actually very unproductive in terms of carbon fixed per metre squared per year. You can see there's some hotspots that are very productive. Around here on the northeast coast of Australia, you've got the Great Barrier Reef, for example. You've got some very productive areas around the coastlines of South America especially. Here we've got the Caspian Sea, largest inland sea in the world. This is an average productivity and it changes throughout the year, seasonally, apart from at the equator. So I'll come back to that and talk about productivity, but you should notice that most of the world's water bodies are not productive, despite the pressure that we put on water bodies to produce food resources for us. Okay, so I'll start by taking a look at the syllabus just for this section, and I've just cherry-picked the bits that refer directly to human demand for water for resources from aquatic bodies. Okay, so mostly they're just statements of fact. Number one, demand for aquatic food resources continues to increase as human population grows and we change our diets, obviously. Number two, photosynthesis by phytoplankton supports a range of food webs. Again, that's self-evident, but I'll talk a little bit about that. Aquatic flora and fauna are harvested by humans. Statements of fact again. The highest rates of productivity are found near coastlines, as I've just mentioned, or in shallow seas, where upwellings and nutrient enrichment come towards the surface to provide nutrients for phytoplankton. And then finally, harvesting of some species such as seals and whales can be controversial, and we'll look at the ethical rights, as it says here. The ethical issues, I should say. Okay, so I could stop there really. They're just statements of fact, but let's put a little bit of detail into each of those things. So first of all, it's worth looking at the price of food. I've got two graph lines here. The blue line represents basically food prices, the food price index, and the red line represents the price of oil. And I don't know if you can see the scale, but it runs from 1990 here to 2012. So a few things occur to me. One, oil prices and therefore food prices are very volatile, but they've generally increased over the last 20 to 30 years. Obviously, because of the high rates of transportation of foodstuffs all around the world, we're very dependent on food prices for what the price of food is. But also because the food industry is so huge, conversely, it also affects the price of oil. So if food prices go up, oil prices go up, but especially if oil prices increase, then food prices do also. Right. Obviously, across the world, there's increasing meat and fish consumption, largely driven by LEDCs turning into newly industrialized countries on their way to becoming MEDCs. As that happens, there's an increase in the expectation of what people expect in their diets. And one of the big expectations is that people will increase the amount of fish that they eat. So before I started recording this, I got some figures. Average population growth between 1961 and 2016 was 1.6% per year. But during that same time, the average fish consumption increased by 3.2%. So all of us are really more expecting more fish in our diet. That increase in fish consumption was actually bigger than the increase in meat consumption over the same time. Also, about 80 to 90% of all the aquatic food resources we get from the sea is for human consumption, which leaves, on average, somewhere between 10 and 20% for animal consumption or making products like fish oils, things like that. However, at the same time, more fish and fish meal that we produce is actually being given to animals. The price of fish is also increasing, or the price of aquatic resources, I should say, is also increasing because more land is being used for things like biofuel growth or palm oil. So therefore, as land becomes more limited, we turn more towards aquatic resources. And then obviously it's worth noting, world oil prices are very volatile. So therefore, the price of food is also volatile, which is bad news for a lot of people in LEDCs. Volatile, but both of them are increasing. And you can see the obvious relationship between the two of them. They follow each other precisely. Okay, next. It's worth talking about what resources we do actually get in terms of aquatic food production. I've split it into 4 sections, or 4 points. 1, we harvest algae. It's becoming more and more popular around the world to eat algae, but it's also a very traditional food resource. Very popular in the Far East, Japan and China, obviously, and Korea. But it's also a traditional food in parts of Europe, for example, Iceland, Norway, Scandinavian countries, Ireland, and Wales as well. Harvesting algae is also used for other products such as alginates, which are jellies that we kind of add to food products, and things like agar, which are the jelly-like material we use for culturing bacteria. They are formed from seaweeds. Okay, next, obviously, fish. This looks like herring fishing, I think. Fish is used for human consumption, but also for animal and pet food. Fish oil, as I've said, and some kind of gelatins. And I found a quotation that said approximately 20 kilograms per person per year is consumed in fish, and that rate is still increasing. Then we come to shellfish. I've included crustaceans, lobsters and shrimp, and clams, oysters. Huge industry as well. And then finally, things you might not think about. Things like alligators and crocodiles are farmed for the skins. Turtles as well. Amphibians, frogs. You might think that frogs' legs is quite a delicacy, but it's another large industry, and it's quite threatening to huge numbers of frogs. So it's not just the French that eat frogs' legs, it's a delicacy in the United States, Europe, across Europe. The biggest importers, I believe, of frogs as a food source are the US and Europe. So it's quite a diverse range of foodstuffs we actually harvest. Okay, and then in the syllabus there was a statement that said we need to consider that phytoplankton is at the base of these aquatic food chains and therefore supports all of these products that we harvest. So here's a fairly simplistic aquatic food chain. It's actually from the Antarctic. And at the base you can see this guy, what's his name? Sheldon phytoplankton. He's supporting all of those other living things in the food chain. So I showed you this map again before. Here it is slightly larger. I hope it's slightly clearer actually. The darker the colour, the lower the productivity measured in terms of grams of carbon fixed per metre squared per year. And the lighter the colour, moving through yellows and up to reds, the more productive. So you can see that the hot spots of productivity are generally around coastlines, and that's where winds and currents force sediment from fairly shallow areas around the coastlines up towards the surface. And then phytoplankton are able to use those nutrients to photosynthesize and produce the basis of the food chain to fix carbon. Other hotspots, some coral reefs. Coral reefs are extremely productive, but in terms of area, they're very small on a global scale. And coral reefs account for about 0.05% of the total productivity of the planet. Obviously, increases towards the equator, where there's a lot of sunlight. But actually, the poles can be very productive as well. But the issue there is seasonality. This graph shows average productivity over the course of a year. So the North and South, the Arctic and the Antarctic oceans become very productive in the summers, obviously because of the amount of sunlight available, but also because the ice pack retreats and makes more water area available for phytoplankton. They become more productive and become unproductive during the winters. I'm not sure I can say much more about that, other than to reiterate what I said before, that oceans are actually, on the face of things, very unproductive, apart from localized hotspots of productivity. Okay. Last couple of slides. The syllabus mentions controversies that surround the harvesting of aquatic foodstuffs. So we could say a few things about that. First of all, it mentions specifically the idea of biorights. Biorights are something that is valued by an ecocentric environmental value system. And it's the idea that the oceans and the ecosystems as a whole have the right to be left alone from human interference. The most noticeable effect of that was, we talked about before, was the moratorium on whaling that was brought in by the United Nations in 1986. It was a knock-on effect of the Stockholm Conference and the other conferences that came after. But that was put in place in 1986. The controversy there is that some countries decided to ignore it to a larger or smaller extent. Most famously, the Japanese continued to whale. This is one of the largest whaling ships in the world, from the Japanese whaling fleet. The Japanese decided to just basically ignore the moratorium and continue whaling under the pretense that it was for scientific research. Other countries that continued to whale included Norway and Iceland. In 2019, the Japanese decided outright to just say that they were withdrawing from the agreement completely and they would just continue whaling. And in 2019, I wrote down that the Japanese whaling fleet caught 256 whales. The Norwegians caught much more. They set themselves a harvesting target or a quota in 2019 of 1,278 whales. In the end, I don't think during the hunting season they caught anywhere near that number, but it was actually larger than what the Japanese caught over the same time. Interestingly, although Iceland has not outlawed whaling, in 2019 to 2020, I believe that the Icelandics did not catch any whales because there seems to be a shift in public opinion that living whales are more valuable to them than dead whales, largely because the tourist industry and whale watching in Iceland has really taken off over recent years. Okay, another controversy possibly is that some peoples are exempt from whaling. So these are Inuit people in Canada that still use traditional methods to whale in small boats. They're permitted by the United Nations to do that because it's considered part of their culture. But it's a very small amount of whales they catch as a people. And I wrote down that between between 2013 and 2018, the Inuit people of North America caught 336 bowhead whales. An argument in favour of whaling is actually that if you don't whale and whale populations are allowed to increase towards their carrying capacity, if they exceed their carrying capacity, they will die naturally. So countries like Iceland, Norway and Japan, to a lesser extent, have argued that it's okay to hunt whales because we're only skimming off. If you do the research, they're only skimming off the whales that would have died by natural causes anyway because of the populations exceeding the carrying capacity. I don't know how much water that argument actually holds. Okay, so I think that's as much as I want to cover. Maybe we could have gone through it in a bit more detail, but you can look at that in your own time as well. So let me just return to the parts of the syllabus that I cherry-picked for this video. Number one, demand for aquatic food resources continues to increase as human population grows and diet changes. I think we covered that, and we talked about the relationship between that and LEDCs becoming newly industrialized countries, and therefore the expectations of people's diets changing. Excuse me. I talked about how phytoplankton supports food webs in the oceans. I went through some examples of flora and fauna that are harvested from aquatic systems by humans. A little bit about productivity and how it changes across the world and how it's largest towards coastlines. And then finally, very briefly, just an idea of how some harvesting of aquatic resources has resulted in controversy, specifically whaling and the UN moratorium on whaling that was introduced in 1986. Okay, I hope that was helpful. We'll speak in the classroom, and in the meantime, take care of yourselves and your family. Okay, goodbye, everybody.